All right, well yesterday, or in our last lesson, we began changing gears just a little bit with these non-right triangles. By the way, what do we call non-right triangles, Quentin? Everything else. Yeah, Jamie? Oblique triangles. What do we call them? Oblique triangles. And for starters, we used a particular law equation to solve our oblique triangles, and that was called the law of... Well, yesterday we started that one. That was going to be my next question. For a while, we've been using the law of sines. There we go. And so for the law of sines, we used it for what three cases of triangles, Jamie?
We used it for the SSA.
Okay, the ambiguous case, right? Anytime that came up.
SAS.
We did not use it for SAS.
SAA.
SAA we did.
And ASA.
Good. So the two that had two angles in them, we used those, and in the ambiguous case, we used the law of sines. And then yesterday we said we're going to use, as Quentin already answered, the law of cosines for which two cases, Quentin? The only case that's not up here yet, as far as ways of proving triangles congruent. Side angles. Of course, we know SSA is not a way of proving triangles congruent. That's what makes it so weird. But so these two ways of triangles congruent, law of sines, because there's two angles. These methods, law of cosines, because there's two sides or more. This one, the weird one, also goes back to the law of sines. And the law of cosines, there's three different ways you could formulate it if you start with a side. Jamie, pick any one of them.
The side A.
Okay, so let's start with a squared equals then.
Then it's b squared plus c squared minus 2bc times the cosine of a.
There we go. And of course, we could do it any of three ways. You could start with the b squared or the c squared. You just have to change out the other letters accordingly. But if we wanted to solve it for an angle, for instance, angle B, we would say that angle B is equal to
a squared plus c squared minus b squared all over 2ac.
Good, and this is frankly the way we're going to use it 5 out of 6 times. So 83% of the time, we're going to use it this way because 83% of the time we're solving for angles. 2 angles here, 3 angles there. Only 1 time out of 6 would we be needing to solve for a missing side. However, if you are missing a side, if you have to use this first, when you get your answer, you better make sure you put it in the memory. It's the one time you have to use a memory here. Obviously, the law of sines, we said we needed a memory for the ambiguous case where there were two triangles. Law of cosines, we got to use a memory if we have side angle side for that first side that we find. You practiced with these last night, page 169. You did numbers 3 through 6. Go ahead and have that out. Also turn in your textbooks, page 169. And excellent. All right, let's take a look at our answers here. Number 3, they gave us angle B with 68 degrees, and they gave us the two adjacent sides, A, 52.35, and C, 93.25. The first thing you had to find was your missing side B. What did you get, Jamie?
I got 88.20.
Good, 88.20 when you use the law of cosines. Now, that's rounded. The exact value went in the memory because you needed that to find angle A, Quentin. 33 degrees, and then you could also use it to find angle C, Jamie.
79 degrees.
79 degrees when we round, since the angles were running the same sides the same. And as a way of checking, we could make sure all 3 angles add up to 180. We never used that as a check on the previous set because that's how we found our angles on the previous set. Here we'll use that as a check. We could also use smallest angle was A, smallest side was A. Biggest angle was C, biggest side was C, everything checks out. Were we good on number 3? Number 4, they gave us a side, side, side. So no memories needed, all nice easy numbers here. And when you found angle A, what did you find it to be, Quentin?
84 degrees. 84
degrees, we'll go 2 sig figs since the sides had 2. Angle B, Jamie?
71 degrees.
71 degrees. Notice the angle got smaller as the opposite side got smaller, and then the really smallest side, considerably smaller side was C, so a considerably smaller angle at C, Quentin?
25 degrees.
25 degrees. And again, a good way to check is make sure they all add up to 180, and they do, or at least add up within a degree of 180, remember, we said. Sometimes sig figs will mess that up. Questions number 4. We're all good. All right, number 5, let me read the answers. You check your answers. Side A, or angle A, 41 degrees. Angle B, 35 degrees. And then angle C, now it should be 104 degrees, but we only are allowed 2 sig figs, so 1.0E2 degrees, which is just frustrating. How many had those 3 angles on number 5? Good. And then for number 6, need to find the missing side A, first of all, to be 25.4 units. That exact value went in the memory, so you could find angle B to be 18.5 degrees, very small angle. And angle C, another smaller angle, 25.5 degrees. We notice that side A is considerably bigger than the others because angle A is considerably bigger than the others, but the angles do add up to right at 180 degrees even with the rounding. Did we get those answers for number 6? Do we need to see any of that worked out?
No, but I have a question. Where do we put the degree symbol for the like 1.0E2? Like where we put this?
Right, so it would be at the end of the scientific notation, so 1.0E2 degrees.
Okay.
Because the entire number is 1.0E2. Yep, good question. Now 1.0 degrees E2. Yeah. All right, good. Why don't you do number 7 and 8? And if you're watching on YouTube and don't have your book, I will be putting 7 and 8 on the chalkboard in just a moment. So number 7 and number 8 from page 169. check your answers. Number 7, did we get that missing side to be 12? 12.08, blah, blah, blah. That should have given us angle A to be 142, but we'll have to say 140 degrees. And then angle C to be 31. Now obviously here, because we rounded 3 degrees off basically, we're going to be at least 3 degrees off of 180 if we added them together. But if you just say, okay, roughly 130, 143, 6, and 31, okay, that adds up to the 180. Questions on number 7? All right. Are we finished with number 8 or are we still finishing?
So I'm finished.
Okay, you're finished, she's finishing. All right. Wow. It's a really small angle. I see, this is a Pythagorean triplet. I was like, 0. Wait a second. This is a right triangle. Okay, let's see what we're doing here. I'm not sure how I crossed out the 90 there. Bad aim. It actually goes a nudge over 180 on the rounded answer, doesn't it? But the actual answers would have added up to exactly 180. Did we get these answers then? All right. Go ahead and set your books aside then, and let's do some more review. We are looking ahead toward a quiz coming up tomorrow that kind of puts all of it together. So let's make sure we're able to bounce back and forth between law of sines and law of cosines. Now, I feel like law of cosines were solid. Do you feel solid law of cosines? And we felt pretty good about law of sines. Just had to be careful on side-side angle. Now let's see what happens when we put it all together. All right? You're going to have to identify the case so you know which formula you should be using. I was hoping to come up during the second hour and talk to you since you had some time. All right, sounds like we're done with the first four. Let's check the first three I've got up here. Good on this another side angle side law of cosines problem. Identified no triangle, just barely missed, but no triangle on the second. And did get a triangle on this one with angles of 21.4 degrees, 46.6 degrees, and that side of 21.6. Erase these two while you're checking. You think you see what you did? Did you get the first angle correct, the 21.4 degree angle?
Yes.
Okay, did you get the 46.6 degree angle?
Yes.
Then maybe recalculate side C and make sure you've got it while I put a couple more up here.
I'm using rounded value for the B, the sine of B. So
Gotcha, instead of the exact value, okay. All right, we'll work on those next two, and like I say, I'll put up another one here in just a second as well. Work this one. All right, be good on these next two.
Yes.
All right, still so far so good. All right. Erase this one then. I've got a couple more. I'm not sure, I may have messed something up just now because I think I did something wrong on my calculator, but you can double check. I messed something up and I think I corrected it.
That's what I got.
That is what you got as well. Okay, so I did correct it correctly then. All right, because surely the three of us wouldn't all make the same random mistake. Good to go on the double triangle. All right. Got one more for you to replace it with. So again, if you're watching on YouTube, you need a little more time to double check your double triangle, pause the video. All right, last review problem for today. I do like being able to check and make sure it adds up to 180. That's a really nice, you have confidence when you finish. Even more so than big side, big angle, little side, little angle. I mean, that's nice too. Alright, I'm going to interrupt you for just a second. I got side angle side, so I'm using the law of cosines, and I plug everything in, and I get that B is 15.299. And I ask myself, wait a second, angle B is only 49 degrees. In what triangle can a 50-degree angle, roughly, be the biggest? That's impossible. You still have 130 degrees left. Even if you split it evenly. So I'm like, there's no way my answer is right. I know I mistyped something. Does that make sense? It's helpful to think about your, now in this case it helps. Like if this had been an 80-degree angle, I might assume maybe it really is the biggest, right? But I know a little early assessment, I know my answer is wrong. I'm going to recalculate it. And don't tell me what it is yet, but I'm going to recalculate because I know whatever I wrote just now, 15.2, there's no way. So I'm going to retry this again. 9.2 squared plus. I forgot to close the parentheses. I just went with equals and took the square root instead of closed parentheses. Equals, take the square root. That's what did it. And we'll go with 9.386 to go into the memory. Do we like that number better? Mm-hmm. Jamie's about to decide if she likes it better. Store one.
Yes, thank you.
I almost didn't store one, and I was like, oh. Quentin, you liking those answers? I assume we're finished with these then and double check them. Okay. Y'all were both ignoring this completely, so I felt like we must have been good to go. Again, if you didn't get a chance to get those answers on YouTube, obviously rewind. Here's the big question. Do we feel like we can handle back and forth between cosines and sines, and you're good at recognizing cases so you know what law to use when? I mean, if in doubt, I'll say this. When in doubt, try law of sines. And if it doesn't plug in correctly, and you're like, you can't solve this, like we talked about, then you have to go with the law of cosines. But it seems like y'all handled it really well. Quiz tomorrow. Do have 3 problems I want you to do for homework tonight. A little bit more practice with cosines, so we're balanced, right? We run the ball as much as we pass it. All right, so let's make sure we do as much cosines as we've done with all the signs leading up to it. Page 169, 9 to 11. Nobody actually runs the ball as much as they pass it. Well, except for Navy. Well, because they run in more than they pass. Anyway, page 169, 9 to 11. We do have a quiz coming up in our next lesson, which will be, again, back and forth, some cosines, some sines, and then we'll get into one last concept, oblique triangles, that'll kind of build on something that we weren't able to do last year. But now that we know trig, we can do it. So that's coming up in our next lesson. Have a wonderful rest of your day, and you are dismissed.